This honors geometry lesson is on the applications of congruent triangles, Chapter 3, Section 3. The objectives are to recognize relationships among triangle parts when triangles are proven congruent. Our goal in the preceding section was to learn when to conclude that two triangles are congruent. Our goal in this section is to deduce information about two segments or angles once we have shown that they are corresponding parts of congruent triangles. To prove that corresponding parts, whether they are segments or angles, of two triangles are congruent, first, you must prove the two triangles are congruent using side, 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 side angle, side, or angle, side, angle. Second, state the parts are congruent by CPCTC, which is the abbreviation for corresponding parts of congruent triangles are congruent. Looking at example 1, we are given that segment BE bisects segment AD, that BA is perpendicular to AD, and that ED is perpendicular to AD. And we want to prove that segment AD bisects segment BE. So we're going to start off with our given statement. Segment BE bisects segment AD, segment BA is perpendicular to segment AD, and that segment ED is perpendicular to segment AD. And our reason for that is our given statement. Now we're going to go back to the first part of our given statement, that segment BE bisects AD. So if segment BE bisects AD, we know that segment AC is congruent to segment CD based on the definition of a bisector. For step 3, I'm also going to go back to my given statement. So I know that segment BA is perpendicular to segment AD, and that segment ED is perpendicular to segment AD. Based on that, I can say that the measure of angle BAC is equal to the measure of angle EDC based on the definition of perpendicular lines and the definition of right triangles. So I'm going to go ahead and mark this in my diagram. The next thing I'm going to conclude is that angle BCA is congruent to angle ECD based on the fact that they are vertical angles. So again, I'm going to mark that in my diagram and mark my reason. So vertical angles are congruent. So now if I look, I have enough information to prove that triangle BCA is congruent to triangle ECD, triangle ECD. Based on my markings, I can see that that is based on the angle side angle postulate. Now what I can conclude is that if the triangles are congruent, then all the angles and corresponding sides must be congruent as well. So I'm going to go ahead and mark what I know. So I now know that this angle is congruent to that angle. I know that this segment is congruent to this segment. And lastly, I know that BC must be congruent to CD because we know that there are 6 correspondence parts, 3 angles and 3 sides that must be congruent in congruent triangles. So based on my markings, I can see that BC equals CE based on corresponding parts of congruent triangles are congruent, or CPCTC for short. Based on that, I can now prove that segment AD does bisect segment BE based on my definition of a bisector. The following proof requires the concept of a line perpendicular to a plane. So a line is perpendicular to a plane if and only if the line intersects the plane and is perpendicular to any line in the plane that passes through the point of intersection. So here we have line BD that passes through plane M at point D. We are also going to look at line BD when it's perpendicular to line AD. So I'm going to mark that line AD is perpendicular to line BD. Therefore, since line BD is perpendicular to line AD, then line BD must also be perpendicular to plane M. We are now going to use this information in example 2. So the second proof, we are given that BD is perpendicular to plane M and that AD is congruent to DC. So I'm going to mark that AD is congruent to DC. So for my first statement, I'm going to put that BD is perpendicular to plane M and that segment AD is congruent to segment DC, and my reason is the given statement. Based on the first part of the given statement, I now know that BD must be perpendicular to AD and that BD must also be perpendicular to DC based on the definition of a line perpendicular to a plane. So that slide that we talked about before. So our reason for this is the definition of a line perpendicular to a plane. For my third statement, I can conclude that angle BDA is congruent to angle BDC. So I'm going to mark this in my diagram. Okay? And that's just based on the definition of perpendicular lines and the definition of right triangles. So again, definition of perpendicular lines and definition of right triangles. Okay, so right triangles. The next thing I'm going to conclude is that segment BD is congruent to segment BD based on that reflexive property. So now if I look at the markings in my diagram, I can see that triangle ABD is now going to be congruent to triangle CBD based on the side angle side postulate, so SAS postulate. And once I know this, I can now go back and mark all the rest of my congruencies. So now I know that this angle is congruent to this angle. This angle here is congruent to that angle here. And that this side is now congruent to that side. So now I can say that angle DAB is congruent to angle DCB based on corresponding parts of congruent triangles are congruent, or for short, CPCTC. This concludes the lesson. If you have any questions, feel free to watch the lesson again. And after watching it for the second time, if you still have questions, write down your questions and see me in the next class.